So we're trying to solve or prove this identity, and we're going to start with the complex side and go to the more difficult side. Well, first of all, I noticed that that's one term and this left side is two terms. So I need to combine them together at some point. Before I do that, though, I'm going to think to myself, do these things, secant is 1 over cosine, cotangent is cosine over sine. Oh. Let's first convert these all into sine and cosine, because then it'll be easier for me to combine them together in my head. So the first thing I'm going to do is convert everything to sine and cosine. So secant is 1 over cosine, so that's 1 over cosine squared x, all over. Cotangent is cosine over sine, minus tan cubed x. Got it? Now I'm going to invert and multiply. So this equals sine x over cosine cubed x. And this minus, remember tangent is 1 over, or sine over cosine, right? So this is sine cubed over cosine cubed. Well, that's nice, because the denominators are already the same. How did I go from here to here, you're wondering? I took that and flipped it and multiplied. Remember how you divide by a fraction? You multiply by the reciprocal. So look at how nice that is, because now I just have sine x minus sine cubed x over cosine cubed x. I can factor out a sine. Sine x times 1 minus sine squared x over cosine cubed x. Okay, see how I factored out? What does this equal? Cosine squared. So I've got sine x times cosine squared x over cosine cubed x. Cancel. That gives me sine x over cosine x, which just equals tangent of x. So tan x, tan x, tan x, tan x,
Okay, that makes sense.
tan x, tan x. Done.